everyone, thank you so much for joining today. My name is Merel Theisen, and I'm really delighted to talk to you today about building machine learning pipelines with Kedro. So before I dive into the deep end with Kedro and machine learning, I'd like to just tell you a bit more about myself. I'm originally from the Netherlands, but have lived in London for about 6 years now. And I started my journey into software engineering and computer science when doing my bachelor's in liberal arts and science in Amsterdam. This is where I started learning about programming, and I took some machine learning courses. And then when I finished my degree, I decided I actually wanted to know more about computer science and really get into this field. So I took a master's degree in computer science at UCL, and then I actually stayed in London after that. So when I graduated, I decided I wanted to continue in the field, and I started looking for jobs as a software engineer. And ever since, I've worked at different places in different areas. So I've worked in academic publishing and advertising, and always as a backend engineer. I've also used various types of programming languages. So I did some Java, I did some Scala, and now I'm writing in Python. And then back in April 2019, I joined Quantum Black, and I joined as part of their product team. So this is the team that builds a lot of software tools that are then used mainly by data scientists and data engineers on studies they do with different clients. And I've worked on several of the different products. So one of them was, for example, around model experiment tracking. But now I'm a member of the Kedro team, and of course that's what we're here today for, to talk about Kedro. So the agenda for my talk will be to first just set the scene a little bit and talk about what building pipelines means and where Kedro fits in. Then I will go into what Kedro is and some of the core features, and I'll show you an example of what it looks like when you're using Kedro on a project. Cool, so the first thing I'd like to do is just to get some terminology out of the way, because I know sometimes we use a lot of buzzwords and we don't always know what we're talking about. So when I'm talking about data pipelines or a data pipeline, I mean the process of taking data from a source, and this source could be a database, a data lake, or it could be several different sources even, then doing something to this data and then storing it again, maybe in the same place, maybe in a different one. And this doing something to it, that could be a machine learning pipeline. So it could be, I have some data and I want to do a prediction, which I'm doing as part of a machine learning pipeline. Okay, then production ready codes. So this is a term that we use when we're talking about code that's robust and reproducible. So that means when I'm running this code on the same data in the same environment, I expect it to always have the same outcome. So it shouldn't change. It should basically, it should be predictable and not give me unexpected things. It should also be easy to productionize. So this means when I've been experimenting and then needed to be ready in a production system, it doesn't take too much time to do this. And then also it should be modular. So it should be broken into smaller, well-defined tasks. So it's both easy to break it down and maybe reuse some of these tasks in a different code base. And it should also be easier to read and test. Then I'd like to just talk a little bit about different roles, because I know different companies have different definitions of roles in technology. So when I'm talking about data engineers, I'm talking about the people or the teams that operate in any data environment, and they usually create the master table. And then they collaborate with the data scientist who leverage the data from the master table and use advanced analytics techniques to extract insights. So they're usually the people building models. And then we have the machine learning engineers, and they are usually the people who deliver this data science code. So this goes from the notebooks into code that can run in production. Cool, so when you are thinking about doing advanced analytics, it's really important to keep your end goal in mind. And the reason why this is important is because depending on the goal, you might need a different approach or a different way of writing your code. So if you're just looking for insights in your data, could be you have lots of data and you just want to know, I don't know, how many users you have or where they're from. Insights might be enough. And in that case, it could be that you can just use some data science code that no one will ever use after this project. And then it also doesn't really make sense to put too much effort into writing the most perfect code, testing it completely, because it will just be thrown away. But if you're looking at actually building a machine learning product, you have to think more about how can I write code that then can rerun constantly and in a robust way, and can also be maintained by other people. And the reason why you need to think about this before starting is because the way you build your code is different depending on the outcome. And it's important to keep that in mind when you're starting, because you might have to use very different tools and different mindsets to get to the end. And obviously you don't want to waste time on the way when you suddenly decide, oh, I need to write a product, and actually you never had that in mind while you were experimenting. And making the step from just writing insights going towards a real machine learning product isn't like a trivial thing, and it comes with a lot of challenges. Because a workflow beyond notebooks isn't just like, oh, I flipped a switch and now it's production ready. And there's a lot of reasons why. So, for example, lots of data scientists work in different ways. So it might be that you're on a project where one person has a specific style of writing their code and someone else completely different, and it doesn't work together. So people have also said that, my code, it runs when I'm running it, but if I send it to someone else, it's not working on that other person's machine. A lot of data scientists have to then learn a lot of tools to create high quality code, because they're just not used to it. And they work in a specific way that's really targeted to writing a good model, but high quality code is a completely different thing. We've also heard data scientists being frustrated about the fact that if they want to write production ready code, they suddenly have to think about stuff like Sphinx for documentation, or ISort and Black to make the code look good, Docker, Python logging, virtual environments, PyTest, configuration, and many more things that don't necessarily come with a data science toolkit. A lot of people then also spend time trying to understand the code base that they didn't write, because it's just so different from what they're used to. So kind of in summary, it's not straightforward to go from your notebooks and your experimental code to a real machine learning product for various reasons. And let's have one look at what a typical data pipeline development journey could look like. It's a long process, and depending on your goal, you might have to go through all of these steps or just some of them. And for example, if you're just generating insights, it might be enough to go through exploration and development. But if you need to go further, like all the way to a stable production system, you might have to go to productionization, deployment, and operation as well. And as you can see, there's also different people involved, or people with different skill sets involved in all these steps. So let's just zoom in a little bit. When you're doing exploration, these might be data engineers and data scientists doing it. It's very likely they just have some scripts or Jupyter notebooks, throwaway code basically. They're not focusing too much on the quality. They're just using some data samples to get some quick insights and get some quick knowledge of what they're working with. Then quite likely they might have to go to the development stage, or maybe they get some machine learning engineers involved as well, work with the full data sets. They might go from only Jupyter notebooks to using a Python IDE or a different coding language, and thinking more about how do I go from all these snippets and these scripts to an actual pipeline. Then, if we look at the next step, this is where things get more serious. So this is where you will think about going into production and getting your code ready for production environments. So this is probably where you have to completely get rid of all the kind of like the crappy code, all the experiments, and have to rewrite some of this stuff so it's properly. You can also test it both in a testing environment and then have it running on your production environment. You might even get a data lake or database in there as well, so you can save and constantly get data from the same place. And then when you go to deployment, this is also where usually some DevOps or MLOps is involved. And when you start thinking about how do I actually run my model, or like how frequently does it need to run, at which times, how should it be triggered, and you'll probably be using production data here. So it won't be just safe toy data. You really have to make sure that you're using production data, and of course use that in a good way. And then the final step, when you really have a stable system that's live and maybe used by other people, you also have to think about, do I need some monitoring to know when the system is maybe not operating so well? Live performance tracking, so this could be for your model itself, when you want to know, is it still performing in the way I expect it to? And then you might also need some logging and debugging to figure out what's happening in the system. And as you can see, like, this whole journey is quite a long one. And when you start out, you might not always think about all the things that are coming up. So it's really good to immediately start with implementing good practices, writing code that can be reused, code that makes sense to other people. And so this is where Kedro comes in. We like to think of Kedro as the bridge between machine learning and software engineering. And Kedro is open source. It's a Python library maintained by Quantum Lab and the team I'm in right now. And it's targeted mainly at data scientists, data engineers, and machine learning engineers. So very technical people. And it is a development tool that helps you and your team build data pipelines that are consistent, robust, reproducible, and deployable. And these are all kind of aspects that point at production-ready pipelines, or code that is stable enough to run in a big system and be used constantly by other people. And Kedro really sets the foundation for creating machine learning code that is easily that you can easily transition into production. So even though you start as maybe experimenting, if you start using Kedro from the get-go, it will be much easier to get that experimental code into a good state and deploy it. And Kedro does it by actually borrowing a lot of concepts from software engineering and then applying that to machine learning code. And these concepts are things like modularity, separation of concerns, versioning, and also making sure things are tested and can be tested. And at the same time, Kedro also addresses shortcomings of things like Jupyter notebooks and quick scripts, because there's a real focus on creating maintainable data science code. So something that can live on forever and isn't just like a one-off thing. And you can imagine, if you've already thought about this from the start, and if you have code that's actually quite usable, you might then also be able to reuse this code in another project. If it's really like modular and you can just kind of plug and play with it. This also means you can become more efficient when you do a lot of different data science projects, because you can use what you've learned from the one project into another one. So Kedro has a couple of kind of core concepts, I would say, that help the framework achieve all these good things. So the first one is project template. Whenever you create a project with Kedro, you get a series of files and folders generated out of the box that helps you kind of get started and have a good setup for your machine learning work. Then there's configuration, which focuses on removing hard-coded variables from your code. So you can easily go from just running it locally to then running it in the cloud or another production environment. And then there's the data catalog, which is an extensible collection of data, model, or image connectors. And it borrows a lot of arguments from Pandas and Spark, so it might already be familiar to you as well, and you don't have to learn something completely different. And then there's the final building block, which is nodes and pipelines, where nodes are pure Python functions that have some sort of input and output, and a pipeline is a collection of these nodes. So now I will go into all these concepts a bit more and tell you a bit about how it works and what the benefits are. And then we'll also see them back in the example, so you know what it looks like in a real project. So first of all, the project template. when you create a project with Kedro, you automatically get a lot of different directories and structure out of the box. So here you can see you get a place for your configuration, your notebooks, logs, Python scripts, tests, project documentation. So you immediately have a place for things. And the benefit is that everyone now has a standard way of working together. So it's not that the one person puts their notebooks in, notebooks and the other just puts them all over the place. You have a centralized folder for it, and you can get up to speed much more quickly with your project. This also helps that your team now can really spend time on documenting your machine learning approach and also actually doing real machine learning rather than having to think about, oh, how do we structure the project and how do we make sure everything works? And obviously, if you use Kedro on all your projects, you then immediately know where to go if you start on a new one. And you don't have to dig through the whole code base to find where things are. And Kedro still has built-in support for Python things, so like Python logging. Our tests are by definition set up with PyTest for your unit tests, and we use Sphinx for documentation. So you also don't have to worry about configuring all of that. It's already set up. And then, of course, it can still be modified. So this is not set in stone. It's more of a guideline of what a good way is of structuring your project. But it could be that you never use Python script, so you can just delete that straight away. And there might be another folder that's really key to the type of project you're doing. Then there's configuration. And configuration, you can kind of think about this as settings for your machine learning code. And our configuration really helps to build your code in such a way that it goes easily from your prototype to production with little effort, because you're forced straight away to think about extracting things, for example, like your credentials. They won't go all over the code anymore. You'll have them in a safe place configuration. We also make sure that your credentials never get pushed to GitHub or place they shouldn't be. And then within configuration, you can also divide it up into different environments, because it could be, of course, your credentials for your staging environment is probably very different from your production environment. So we give the ability to divide up all your configuration. So you basically have one way of setting it up, but divided by the type of environment you need this type of data in. And it also helps you kind of keep everything in the same place, because a config is not just for credentials, it's also requirements for your data, logging you want to do, and all the parameters that might be used throughout your code. Then there's the Kedro data catalog. And the data catalog manages loading and saving of your data. So this basically means that you don't have to worry about writing and reading from files or databases. Kedro does that for you. And the good thing is you don't need to learn a new API, because we borrow, load, and save arguments from the Pandas and Spark API. So hopefully, if you're a data scientist or data engineer, you probably already know this. And you can use it both as code or YAML API. And it also allows you to do data versioning. So the data catalog, you should see it as a collection of all the data you are using in your pipeline. And then when you enable versioning, this means you can even keep track of what version of your data was used in which run, which then, of course, led to a specific performance of your model. It will also take care of reading credentials. So it uses the configuration to make sure that it reads the right credentials for each environment, and of course do that in a safe and secure way. And the good thing is this data catalog is extensible. So we already support quite a lot of different types of data, so CSVs, Excel, JSON, Parquet, and we build on top of a lot of different things like Pandas, Spark, Hadoop. But it could be, of course, that you're using a new type of database that we haven't thought about yet. So we made it extensible so people can also add their own implementation and things for the libraries they are using. And then kind of the final big building block of Kedro are nodes and pipelines, where nodes are functions pure Python functions, and they have an input and an output. And when I say pure function, it basically means that we kind of suggest to people that they should make sure that the input is never modified. So pure function is something where you don't have any side effects. And obviously, if you're using data, you have specific types of data you don't ever want to change, like your raw data. You don't want to lose that. So we advise you to write your notes in a way that you don't modify things. And node definitions, they also support different types of input. So you can just use one data set, or you can also do table joins. You can also produce multiple outputs. So for example, if you need to split your data into a training set and a testing set, you can use nodes for that as well. And then we have pipelines, where a pipeline is a DAG, or a directed acyclic graph. And this is a collection of nodes. So a pipeline consists of one or more of these node definitions, and there's a defined relationship. And the cool thing about Kedro is that Kedro will figure out for you how it should run the pipeline. So you basically just have to define, these are the nodes that are part of my pipeline, this is the input for each of them, and this is the output, and then Kedro will figure out how to run it in the correct order. So to give an example, if node 1 produces a data set that's needed by node 3, but node 2 doesn't need it, Kedro might run in such a way that 1 and 2 go at the same time, and 3 only waits until it gets the output for 1. So Kedro does that for you. So these 4 concepts are kind of part of the core Kedro library. And then we have some other things that make working with Kedro a lot easier, and also help you going through the whole flow from experimentation all the way to the end and doing great teamwork. So one of them is our pipeline visualization, or Kedro Viz. And we have a demo for this. So if you want to see or just play around with it, you can go to Quantum Black Labs GitHub and go to Kedro Viz, where you can see a diagram like this in real life and play around with it. So this pipeline view has been generated from codes. When you create your own Kedro project, you will be able to run Kedro Viz, and it will look at your pipeline definitions, look at your node definitions, all the data that you've defined, and put it in a flowchart like this. And this really helps you to figure out how does my data flow through the pipeline? How do I get to my end result? And what does the structure actually look like? And it also really helps you to talk to your team members. So it might be like you have a new person joining the team, or you've been working on one part of the pipeline, and now you connect it all and you actually see what the bigger view is. And of course, maybe there might be a less technical person on the team that doesn't really want to go through hundreds of lines of codes, but this might be a really cool way of still explaining to them how your model works and how your pipeline works. And then there's the point of deployment. Because of course, as I mentioned in the beginning, if you are building a machine learning product, you do need to deploy it at some point. So Kedro supports a lot of different type of deployment modes. So we help with single machine deployments. So if you want to, for example, use Docker, we actually have a Kedro Docker plugin that will generate an image of your project, so you can basically just deploy that on a server. Then there's also a Kedro package command, which makes sure to package your pipeline as a Python project that then can be run and deployed to other machines. And we also support the distributed application deployments. So if you want your Kedro pipeline to run on multiple computers within a network, we have support for that as well. And some of these tools on the bottom we have actual plugins for. So Docker is one of them, Airflow is another, but we also support deployment with Argo, Kubeflow, AWS Batch, Amazon SageMaker, and Databricks. So you should be able to deploy Kedro on most of the environments you're using. So now you might be wondering, okay, this is cool, but where does Kedro actually fit in the ecosystem of the already existing tools out there, like when I start a project, when should I start using Kedro? So the answer is actually straight from when you start your project, because you can use Kedro from the moment you have raw data to ingest, when you need to do processing of your data, so maybe when you need to do cleaning and joining, when you're engineering your features, and then when you're training and validating your model. The Kedro flow kind of stops when you start deploying. And the reason is Kedro really focuses on how you work while you're writing a standardized and reproducible data science code base. And it doesn't really focus on how you would like to run it in production. So that's kind of where Kedro functionality stops, because kind of the responsibility of what time will my pipeline run, or how often, and how do I know if it failed or if it's successful, that's for tools that we call orchestrators. So these are things like Airflow, Dexter, Prefect, Luigi. And so these take care of that part of the running of the pipeline, whereas Kedro really, Kedro really focuses on helping you make something that can be deployed. So writing the machine learning pipeline in a way that it then can be run by things like Airflow, Prefect, and Luigi. Cool, so that's Kedro in a nutshell. So now I'd like to dive into an example. And this example is taken from our documentation, our tutorial, and it's called the spaceflight tutorial. And with this example, we just have to kind of imagine we're living in the year 2160 and space tourism is booming. So people want to go to the moon and other places. And it's your job to make a model to predict what the price is for a trip to the moon and back. And of course, we're using Kedro for this. So in this example, actually the full example has both a data engineering pipeline and a data science pipeline. But for this talk, I'll just zoom in on the data engineering side of things. And our goal is to create a master table from 3 different data sets. And the first thing we've done is we've run Kedro Viz to show what this pipeline looks like. So we have some data sets at the top. That's what this icon indicates. Then we get nodes with the F for function. Then we have some intermediate data sets. We've got another node, and then we end up with our result, which is the master table. So if we zoom in to each of these steps, we can see, firstly, we've got data from companies that offer space flights. We've got data about the space shuttles themselves. So what types of aircraft or spacecraft do we have? And then reviews. So how did people find these trips? Were they worth their money, or were they really bad? And then we have a pre-processing step where we do pre-processing on the company's data set and on the shuttle's data set. And these are 2 separate nodes. So they happen in 2 separate node functions. And then each of these pre-processing steps creates an intermediate data set. So we save our result in between. And then we have a node called create master table, which takes these pre-processed data set as well as the raw review data. It could be that the review data is already really clean and we don't really need to do anything with it, so we can just consume it as is. And then all of these are combined to create our master table. And you can imagine if this is a real project, and what you will see in the full tutorial is that this is then the result that the data scientist can take on. So it's a real collaboration between the data engineer and the data scientist on this project. And so when you need to add data, this is where the catalog comes in place. And we've got a small example of what a catalog entry for companies and for shuttles would look like. So this is an example of when you use the YAML format. So we have catalog YAML, and we have companies. So this key refers to the name of our data set. We've specified the type. So in this case, we're leveraging pandas, and it's a CSV type data set. And then we specify the file path. So in this case, it's just stored somewhere on the local computer, but this could also be an entry to an S3 bucket or a database somewhere. And then we've also specified that this is the raw layer. And maybe you already noticed, but in this image, you can see these different layers. So we've got raw, intermediate, primary. And this is something that you will see kind of linking to the backend code for Kedro, and then the visual part as well. So you can even divide up your pipeline in a way that shows you which stage of data processing you're at. And then shuttles is fairly similar, only here we are using an Excel dataset. So yeah, that's how you add data in Kedro. And Kedro will then figure out, because of all the details you've given, the type of dataset, where it is, it will then figure out how to actually read it and process it in the correct way. Then let's have a look at how you add a node. So a node, as I said before, is just a Python function. And so the definition for this preprocessed companies, it looks a lot like just any normal Python function, because that's what it is. So this one takes a data frame and looks at a specific column around company rating, and then applies another function, parse percentage. And then that's your node. So this is just how you create a node. And then pre-processing shuttles would be something very similar, probably just a different type of processing we're doing. And then the pipeline itself, that's just a collection of the nodes we have. So as you can see, we have 3 nodes, and these all map to the nodes here. So pre-processing companies, pre-processing shuttles, and create master table. And for each of these nodes, what we need to say, or what we need to specify, is the actual function that needs to be applied in the node. So this one, pre-processed companies, that's the one we saw here before. Then we say what the input is, and this input is companies, which is the key from our catalog. So it just references that key, and then it knows that's the dataset I should be using. So if you, for example, if you put a name of a dataset that doesn't exist in the catalog, you will see an error like, I don't know what this data is, I don't know where to find it. And then we have outputs. And in this case, we have pre-processed companies, which is this intermediate dataset. Shuttles is very similar. And then for the master table, you might want to have a look at the input. So this is a list of different inputs. So you don't just need to specify only one dataset. You can put as many as you need. So in this case, we have a list of the pre-processed dataset and the reviews. And that there is your pipeline. So yeah, the final step that remains is just running your pipeline. And that's as easy as doing Kedro run, and it will show you kind of the process while it's going. So it tells you, okay, I'm loading some data, I'm running a node, saving it, and then I've completed the tasks. So a task is usually mapped one-on-one with a node. So you know exactly how many of your nodes still need to run. And then the blue, you can see this is another node. This is the company's node. And then finally, we get our master table node, and it tells us I've completed everything. And yeah, this output can be anything you want. So in this case, of course, we're doing a data engineering flow. So our expected result is a master table, but it could also be that you need to know the accuracy of your model. So that would be maybe part of your data science pipeline. And that's, yeah, then you have a Kedro project and a Kedro run. So our teams at Quantum Black have been using Kedro for a while now, and most of them actually do use Kedro in their daily work. So we've already been able to see some of the benefits of using Kedro rather than just the old data science flow where you were writing notebooks and then at the end you frantically have to make something that is robust and deployable. So the first thing we found is that teams are much more able to accurately estimate how long it will take to go from the start of the project to when they're experimenting to actually produce something that we can call production-ready code. They also have to spend a lot less time on refactoring because they go into the project with a mindset of creating code that is reproducible and is modular and is tested, etc. And so ultimately, they can spend much more time on solving the actual business problem and doing modeling. We've also found that, Kedro really helps with code reusability because from the get-go, you really start thinking about how can I produce code that's environment, data, and like computer agnostic. So this machine learning code can run anywhere, really. And this also helps you benefit from that you've actually written something that you might be able to reuse in another project. It could be that you're using similar data, so you don't have to rewrite the notes for this. You can just copy it and plug it into your new project. And then there's also the real benefit of increased collaboration. As I kind of told you with the example, that example showed how a data engineer and a data scientist could each write a pipeline in Kedro, and then both of them would be connected and form the full pipeline. So this is not just a tool for one of your one of the parts on the whole journey of developing a machine learning pipeline. It's something that can be involved in the whole flow. So data engineers, data scientists, machine learning engineers, and even your DevOps can gain really good benefits from using Kedro because they use the same language and they're also kind of using the same software engineering best practices because it's all ingrained in this code base and it all connects together really nicely. And then finally, we've also found that our developers gained a lot more confidence in writing really good production-ready code because through using Kedro and seeing how Kedro kind of structures things and makes you think about how you write your pipeline, it kind of embeds these software engineering principles in your way of working, and you get real hands-on experience with it. Right, so that's everything I had to tell you today about Kedro, how it works, and what are some of the benefits from using Kedro on your data science projects. So now I have only one thing to say. It's kind of a call to action to you. If you find Kedro really interesting to use, or maybe you want to know more about the code, you might be a software engineer like me and be really curious in how we work, then I definitely advise you to go to one of our channels. So we have a GitHub where you can find the code. We really encourage people to tell us what you think about Kedro. So leave comments, suggestions, leave PRs if you have a great contribution. You can join our Kedro community channel on Discord. So this is really community driven. We have a lot of users helping each other with different use cases. Some of our team are on there as well. So you get some insights into best ways of working with Kedro. We have Stack Overflow, so if you have questions about there might be a bug or you need some help getting started, Stack Overflow is the place to go. And then there is our root to docs. So these are all the documentation docs we've written about Kedro. So much more detail about the things I've explained to you today. But there's also tutorials and hands-on use cases you can try out. So yeah, I hope you enjoyed my talk, and maybe I'll see you on one of the Kedro channels.